The International Space Station is a massive space laboratory that orbits Earth, allowing astronauts to live and work in space. It's a collaborative project between space agencies like NASA, Roscosmos, ESA, JAXA, and CSA. The ISS is not just a research platform, but also a symbol of international cooperation in space exploration. It orbits in low Earth orbit approximately 400 kilometers above our planet, and it travels at a speed at around 28,000 kilometers per hour. Its main purpose is to allow astronauts to conduct scientific research and experiments in a unique environment where gravity has little to no effect, known as microgravity. The ISS relies on solar power for most of its energy needs. The station is equipped with large solar arrays, which are accordion-like blankets that unfold once the ISS is in space. These arrays capture sunlight and convert it into electrical energy, powering the entire station. Each solar array is designed to generate between 84 and 120 kilowatts of electricity, enough to power over 40 homes on Earth. To ensure the solar arrays are always positioned to capture the maximum amount of sunlight, they are mounted on gimbals. Gimbals are rotating mechanisms that allow the arrays to follow the sun as the ISS orbits Earth, which ensures continuous power generation. Since the ISS orbits the Earth every 90 minutes, it spends a portion of each orbit in Earth's shadow, where sunlight is blocked. During this time, batteries on board the ISS store excess solar energy to keep the station running when the arrays can't produce electricity. Once the energy is collected and stored, it needs to be distributed throughout the ISS. The electrical power is used for a variety of functions, including running scientific experiments, maintaining life support systems, and powering communication and navigation systems. The efficient use of energy is critical for the survival of the astronauts and the success of their missions. Managing temperature in space is one of the biggest challenges for the ISS. In the vacuum of space, there's no air to absorb or transfer heat. As a result, when the ISS is exposed to the sun, it can become extremely hot, while the side facing away from the sun can get extremely cold. To maintain a comfortable and safe environment for the astronauts, the ISS has a complex temperature control system. The key to regulating temperature on the ISS is the use of radiators. Radiators are large panels that are designed to get rid of excess heat by releasing it into space. The ISS's systems and equipment generate a lot of heat, and the radiators prevent the internal temperature from rising too high. To keep the station from becoming too cold, temperature management loops are used. These loops contain fluid that circulates around the ISS, absorbing excess heat from equipment and modules. The fluid is then carried to the radiators, where the heat is released into space. This system ensures that the ISS maintains a stable temperature, allowing astronauts to work and live comfortably despite the harsh conditions of space. This balance between preventing overheating and keeping systems warm enough to function is essential for the operation of the ISS. Without proper temperature control, the equipment could overheat and fail, or the astronauts could be exposed to dangerously cold conditions. The ISS is designed to keep astronauts alive and healthy while they work in space. To do this, it has several life support systems that provide clean air, water, and a comfortable living environment. One of the most important systems is the oxygen generation system. Oxygen is produced on the ISS using a process called electrolysis. In this process, electricity is used to split water molecules into hydrogen and oxygen. The oxygen is then released into the cabin air for the astronauts to breathe, while the hydrogen is usually vented into space or used for other purposes. Another crucial part of the life support system is the carbon dioxide removal system. As astronauts breathe, they produce carbon dioxide, which can become harmful in high concentrations. The ISS uses scrubbers and filters to remove CO2 from the air, ensuring that the air inside the ISS remains safe to breathe. Water on the ISS is also carefully managed. The station has a water recycling system that purifies water from various sources, including sweat, urine, and humidity from the air. This recycled water is then cleaned to be safe for drinking, cooking, and hygiene. This system is essential because it reduces the need to constantly send fresh water from Earth, which is both costly and difficult. The ISS also maintains a stable environment for astronauts through temperature and humidity control systems. These systems ensure that the temperature inside the station stays at a comfortable level, and the humidity is kept low enough to prevent mold or bacteria from growing. Together, these life support systems make sure the ISS is a livable and safe place for astronauts to stay during their missions. The ISS is made up of different modules, which are like connected rooms that provide both living and working space. These cylindrical modules are pressurized, meaning they are sealed to keep the air in and the vacuum of space out, allowing astronauts to work and live comfortably inside. The US segment includes important research modules, such as Destiny, the core laboratory where most scientific experiments take place. This lab is packed with equipment that allows astronauts to study everything from biology to physics in a microgravity environment. The Kibo laboratory, which belongs to Japan, has a special feature, a small porch where experiments can be placed outside in the vacuum of space. This allows researchers to study how different materials and objects react when exposed to space directly. On the other hand, the Russian orbital segment focuses on the basic necessities of space life. It includes systems for life support like oxygen generation and water recycling, as well as docking capabilities for spacecraft arriving from Earth. The Russian segment also handles propulsion, helping to adjust the ISS's orbit and keeping it stable. Another important module is the Tranquility module, which contains the cupola, a large window that provides astronauts with breathtaking views of Earth. The cupola is not only used for observation, but also for monitoring spacewalks and docking activities. Together, these modules form the interconnected structure of the ISS, allowing astronauts to live, work, and conduct research in space for extended periods. Communication is vital to the operation of the ISS. The station has sophisticated communication systems that allow it to stay in constant contact with ground control on Earth. These systems relay data back and forth, providing real-time updates on the ISS's status, as well as allowing astronauts to send back their findings from scientific experiments. The ISS uses radio waves to transmit this information through satellites orbiting Earth, which then relay it to ground stations. This system ensures that mission control can monitor the station and provide support to astronauts whenever needed. Inside the station, there are also intermodule communication systems that let astronauts communicate with each other, even when they're in different parts of the station. These systems are crucial during spacewalks and other operations where astronauts need to coordinate their actions across various parts of the ISS. Additionally, the communication systems on the ISS allow for science data transmission. This means that the results from experiments conducted in space can be sent down to Earth in real time, allowing scientists and researchers to analyze the data and even adjust experiments as needed while the mission is still ongoing. Astronauts living on the ISS have designated living quarters, which are small, individual sleep stations where they can rest and have some personal space. Each astronaut has their own area, equipped with a sleeping bag, computer, and a few personal belongings. There are also hygiene facilities, including a toilet and a small area for washing up with wet towels, since showers are not possible in microgravity. Moving around in zero gravity is a unique challenge. Without gravity to hold them down, astronauts must use handrails and footholds attached to the walls to guide their movement. They push off one surface and float to the next. Special care is taken to avoid floating out of control or bumping into sensitive equipment. The layout of the ISS helps, with connected modules that allow astronauts to move between different areas, such as labs, living quarters, and workspaces. For tasks outside the station, astronauts use Canadarm2, a large robotic arm that can be controlled from inside the ISS. This arm helps move large objects or equipment and supports astronauts during spacewalks. One of the primary goals of the ISS is to support scientific research that cannot be done on Earth. In the station's microgravity environment, scientists can perform experiments that are impossible in Earth's gravity. For example, researchers study how plant growth, human health, and material properties change in space. These findings help us understand things like how space travel affects the human body and how materials behave without gravity. The ISS is home to many advanced instruments that can help with scientific research. The alpha magnetic spectrometer is a device that collects data on dark matter, antimatter, and cosmic rays. These are particles and forces that scientists are still trying to understand, and the ISS provides a perfect platform for studying them. Another important instrument is the Orbiting Carbon Observatory 3. This device monitors carbon dioxide levels in Earth's atmosphere, helping scientists track climate change and understand the impact of human activity on the planet. By observing Earth from space, the ISS gives us valuable data that cannot be gathered from the surface. Keeping the ISS operational requires regular maintenance and repairs. Sometimes, astronauts need to go outside the station to fix problems. These spacewalks, or extravehicular activities, allow astronauts to perform repairs on the station's exterior, install new equipment, or adjust existing systems. Spacewalks are highly planned and involve a lot of preparation to ensure the astronauts' safety. Astronauts don't handle all repairs alone. They're supported by robotic tools like Dexter, a robotic handyman that helps with maintenance tasks outside the ISS. Alongside Canadarm2, these robots can handle delicate work, like replacing parts or moving equipment, which reduces the need for astronauts to risk going outside as often. Before an astronaut goes outside for a spacewalk, they must go through the airlock system. This system allows them to safely leave the pressurized environment of the ISS and enter the vacuum of space. Once outside, they work on repairs using special tools and equipment designed for use in zero gravity. The ISS orbits Earth in a region called low Earth orbit, at an altitude of about 400 kilometers. Even at this height, Earth's atmosphere creates a small amount of drag on the station, causing it to gradually slow down and lose altitude. To keep the ISS in the correct orbit, it must be periodically adjusted, a process called reboosting. This is done by firing engines on the Russian modules of the ISS, which push the station higher and keep it from falling back to Earth. In addition to reboosting, the ISS has propulsion systems that help it maintain the correct orientation and adjust its position as needed. These systems ensure the station stays on course and can make minor adjustments to avoid space debris or align properly for docking spacecraft. The ISS depends on regular docking of spacecraft to support its crew and deliver essential supplies. The station is equipped with several docking ports, which allow various types of spacecraft to connect. Spacecraft like Russia's Soyuz, SpaceX's Dragon, and other cargo ships from international space agencies can bring fresh supplies, new crew members, and scientific equipment to the station. These ships are crucial for delivering necessities such as food, oxygen, fuel, and materials needed for ongoing experiments. Cargo transport to the ISS occurs through scheduled resupply missions, which ensure that astronauts have everything they need for daily living and research. Once a spacecraft arrives, the crew unloads the cargo, and used or unnecessary items are loaded onto the departing vessel for disposal or return to Earth. Docking can be either automated or manual. Some spacecraft, like the SpaceX Dragon, dock automatically using advanced sensors and navigation systems. In other cases, like the Soyuz, astronauts manually guide the spacecraft to dock with the ISS. Whether automatic or manual, docking is a highly precise operation to ensure the safety of the crew and the integrity of the station. Maintaining a stable temperature inside the ISS is critical for both astronauts' comfort and the proper functioning of the equipment. The station uses thermal radiators to get rid of excess heat. These radiators are large panels located outside the station that release the heat generated by equipment, solar exposure, and human activity. Without these systems, the inside of the ISS would become too hot, especially since there's no atmosphere to naturally cool the environment as there is on Earth. Waste management is another essential aspect of life on the ISS. Solid and liquid waste from everyday activities, including human waste, is stored in special containers. Some of this waste is jettisoned into space, where it burns up upon re-entry to Earth's atmosphere, while other waste is returned to Earth aboard cargo ships. For example, used supplies and equipment are sent back on spacecraft like the Cygnus, which burns up during re-entry, acting as a garbage disposal system. As the ISS continues to age, new challenges are emerging. The ISS, launched in 1998, is approaching its planned decommissioning in 2031. Signs of aging, such as air leaks and structural wear, are becoming more frequent, requiring more frequent repairs and maintenance. This aging structure presents a major challenge for the station's future functionality. In response, space agencies and private companies are planning for a future where private space stations take over some of the ISS's roles. Companies like Blue Origin and Axiom Space are already developing their own space platforms, which could host astronauts and scientific research in low Earth orbit. These private stations could allow the research and exploration efforts currently supported by the ISS to continue even after the ISS is retired. As the ISS prepares for decommissioning, it remains a functional platform for international space science and exploration. The knowledge and technology developed on the ISS will inform future space missions, whether aboard private space stations or in deeper exploration efforts like missions to Mars or beyond.